Okay, hello there. This is Sorgar from IT Mutual Electrical Department, and from today onwards, we are starting our physics AIT series also. Okay, so we will take solve four problems in this session. So the first problem statement is the statement is clearly mentioned. Wait a while. Okay, so it is given there is a disk, right? It is given there is a disk, and there is a particle which is incidentating at a particular angle. We don't know. Let's call it there is a velocity something. Let's call it v. It is given an initial velocity of v is equals. Wait a while. V is given important as a velocity of V is equals 5 phi cap minus 10 j cap. Fine. And it is a disk and it is a mass from same particle is of same mass as of the disk. The same particle of disk and it is the radius r. Okay. Fine. And is the mass of the particle which is striking the disk is also has the same mass, that is n. And the radius is r. And it is strike at that point which is located at a distance r by 2 from the center. Okay. So what we have to calculate the coefficient restitution between the coefficient restitution corresponding which collision has taken place is given as E equals 1, and the coefficient of friction between colliding is to be mentioned mu is equals to 0.2. So what we have to calculate the angular velocity of the disk, angular velocity of disk after the collision, angular velocity of disk after the collision, time period of the particle after collision, time period of particle after collision, particle after collision. Okay, and the angular velocity of the disk, time period of the particle after collision, and linear velocity of disk, linear velocity of disk, linear velocity of disk. Okay, these things, these three things you have to calculate. Okay, so first understand what is happening in the scenario. It has imparted a velocity which is in the 5 I k minus 10 j k direction. That implies it has a linear velocity of 5 and vertical velocity of 10. Okay, so if the coefficient restitution is 1, that implies after the collision, it will have a vertical velocity of the same magnitude as of 10. And the horizontal velocity we don't know, let's call it v. Fine. So during collision, what we can say is the normal impulse is provided, which is given to the disk in the that direction and the particle in up direction. What we can calculate as integral of n dt is given as m into 10 minus of minus 10. That is 10 plus 10. That is 20 m. So the integral of n dt provided to the particle as well as the disk is 20 m. Okay. So the the particle has the after collision has a particle. Let's suppose it has a velocity v in the rightward direction. Fine. So what we can write is we can apply the impulse momentum theorem on the elementary particle. So what we know is integral n dt is 20 into m, and the particle has a velocity of v, and let's call it the particle has the backward force which is experiencing this integral of f dt and the mass m. तो ये क्या हो जाएगा m into v. Wait a while. Let's apply the impulse momentum theorem at once. So the initial velocity is in the rightward direction. That is 5 into m minus of integral of f dt is equals to m into v. Okay, I am considering the total slipping condition, the maximum value of the integral f dt. Of course, he will try to of course makes the relative velocity zero. So as the disk is on the rest position initially and it is free to rotate, it is placed on the smooth horizontal surface. It is mentioned in the question. Fine. So what will happen effectively is it will provide two impulses on the disk, one in the downward direction and one in the that wait a while, one in the that direction j, and let's call it j1 and upward j2. So of course j2 have no effect significantly on the disk because it is presenting on the ground, right? So it will bounce with the normal provided by the ground itself. So what we can think is j1 is giving a horizontal velocity to the disk as well. So what we can think is integral of f dt is nothing but mu into integration of n dt, and that is m into v. So integration of n dt is given as 20 into m, which we have calculated earlier as well. So it is given 5m minus mu, and mu is given 1 by 5 multiplied by 20 into m is equals to m into v. That implies the linear velocity imparted to the particle after colliding is v equals to 5 minus 4m, that is m upon, that is 1 meter per second. Okay, okay, fine. So we have to calculate the angular velocity of the disk as well. So what we know is uh, the the impulse which is acting in the horizontal direction, that is J1. J1 is given by mu into integration of n dt, and it located at a distance of r by 2. So what we can write is it has a linear velocity of v, which we have calculated as 1 meter per second. And for the calculation of the angular velocity, we have to write the torque equation. And of course, we will write a angular momentum impulse momentum theorem. That is given as J1 into r upon 2 should be equal to mr square by 2 into omega. And that is given as, sorry, wait a while, mr square by 2 into omega. Fine? Okay, wait. mr square by 2 into omega. 2 gets cancelled. So J1 is clearly mu into integration, and it is 1 upon 5 into 20 of m is equals into r should be equal to m into r square into omega. And of course, it's going to be 4mr should be equal to mr square into omega. Omega is equal to 4 upon r, and r is 20 centimeters. So omega will be equal to 4 upon 20 upon 100. So it's 400 by 20. That is 20 meter per second. 20 radian per second. So omega is 20 radian per second. Okay. So now what it has given is we have to calculate the time period. So one thing which we know clearly, that the initial velocity of the particle after collision, sorry, the velocity of the particle after collision is 1 meter per second, and the upward is 10 meter per second. So the time of period is clearly is given as 2 ux into uy upon g. That implies it is 2 into 10 into 1 upon 10. That is 2 seconds. So this answer is 2 seconds. This answer is 20 radian per second. And this answer is uh, 1 meter per second. Okay. Next, move on to the other question. So there is two things which we can calculate even. We have to calculate the disk of the disk velocity, or the a second, wait a while. It is not 1 meter per second to be precise. It is 1 meter per second is the velocity of the particle which is colliding, not this one. Okay. So calculation of this velocity, what we should write is, let's call it v prime. J1 should be equal to m into v dash. So J1 is mu into m, sorry, 20 mu m should be equal to mv dash, and that is 20 multiplied by 20 into m got nullified. So 20 mu is 1 by 5, that is v dash equals to 4 meter per second, right? So v dash is 4 meter per second. Fine. And then this v is the velocity of the particle. Okay. So I think this is clear now. Fine. Let's move on to another question. So another question is from rotational motion, and it is given. Let's solve it with easy problem first, then we move on to another one. It is also on the rotational motion itself, and problem is based on the radius of curvature concept. So in this problem, we will basically nourish our concept about radius of curvature. Okay, let's take a problem. Problem statement is there is a sphere which is basically pure rolling on a surface, and imparted has a velocity of center of mass that is equal to v naught. At a distance of r by 2 from the center, we have to calculate the radius of curvature of that point. Let's call it this point as a. So we have to calculate the radius of curvature of point A. Radius of curvature of point A. Fine. So think once. What we can do is we can if we are able to calculate. Wait a minute. And it is given it is a sphere. Okay. So what we have to think is if we are able to calculate the velocity and acceleration of the particle located at the point A, we can easily calculate the radius of curvature of that point. So if it is performing circular pure rolling motion, that implies there should be angular velocity as well, and that is given by omega is equals to v naught upon r for the instantaneous rest of that point, right? Fine. So this point A has clearly velocity of v naught plus v naught by r multiplied by r by 2. That is given by 3 v naught by 2. Fine. So it has a velocity of 3 v naught by 2. Fine. And of course, the acceleration provided to the particle, wait a while, guys. The acceleration to the particle at the center is, of course, there is no angular acceleration. So the single acceleration is centripetal acceleration, that is v naught square by r. And in this case, the particle has velocity. एक second. This particle has velocity 3 v naught by 2, and this value is r by 2. So the acceleration of particle with respect to this point is uh, 3 v naught by 2 square divided by rc should be equal to acceleration of that point, and that is uh, omega square into r by 2. Fine, because the particle located at all points has the same angular acceleration with respect to that point, and with respect to that point, it has an omega angular acceleration, and that point is located at a distance of r by 2. That should be equal to omega square into r by 2, and omega is clearly v naught v naught by r. Once substituting the values, we got 9 v naught square upon 4 rc should be equal to v naught square by r square into r by 2. That implies what we got as 9 by 4 rc should be equal to 1 by 2 r. That implies 18 r should be equal to 4 rc. That implies rc is equal to 9 r by 2. डन है. आगे बढ़ाते हैं. ये क्वेश्चन करते हैं काइनेमेटिक्स का इजी वन, फिर आगे बढ़ते हैं ये रोटेशन का मॉडरेट लेवल क्वेश्चन करते हैं. ओके. Problem statement is a particle is moving in the xy plane according to the equation x is equals to 4 multiplied by 1 minus cos 60. y is equals to x is equals to, wait a while, it's a y equals to, okay, fine. So it is given y is equals to 4 into 1 minus cos 60 and x equals to 4 sin t. X is equal to 4 sin 60. So what is the distance covered by the particle in 6 seconds? We have to calculate in 4 seconds, in fact. Fine. So clearly, what is the distance covered by the particle? It's basically square root of uh, basically speed into time, right? Speed into time. And what is the speed? The speed is magnitude of velocity. So we can think of what is velocity in the x direction. That is 24 multiplied by, हमें calculate क्या करना है? Distance traveled by the particle whose motion is governed by these equations. X y coordinates are given by these functions of the time. Distance covered in 4 seconds. Distance covered in 4 seconds. So what is V1? Vx is 24 into sine, 24 into cosine of 60. And what is Vy? Vy is 24 into sine 60. So clearly the speed of the particle is constant, and that is Vx square plus Vy square is clearly at all instant, square root, it is 24. So distance covered by the particle in 4 seconds is speed into time, and that is 24 into 4 is 96. Isn't this crazy question? I hope you enjoy it. Next, move on to another question. So the problem statement is there is a given. एक second. हाँ, there is a given a uniform spherical shell. Patiently करें आप इस बाउंड को. There is a given uniform spherical shell. At a distance of h, it is provided an impulse. Its radius is r. Its mass is m. At a distance h from the center, it is imparted an impulse of j. And because of this, it has acquired a center of mass acquires a horizontal velocity, center of mass of velocity of a v naught. It is given in the question itself. Okay, so what we can say is after just after providing the impulse, its center of mass acquires a velocity of v naught. So clearly, if h is a non-zero number, so there should be must a angular velocity of the particle, because the angular uh, because when you apply the angular momentum impulse momentum theorem with respect to that point, it is clearly experiencing a torque as well for a dilute time, no doubt, but there should be angular velocity as well after the just implementation of the impulse, because this is not passing through the center. Fine. So the first step itself, the question in the mention is to sort of we can calculate this kind of things as well. So what we can say is in fact what is provided itself, uh, the disk starts pure rolling after some time. So let's say it acquires its center of mass acquires a velocity of vcm, and that is omega. Fine. So what we have to calculate, what is the value of h, and what is the energy dissipated in this total journey. Okay, fine. So first, what we can write the simple equations, right? So clearly, it is after the implementation of the z impulse, sorry z impulse, it has been acquired a center of mass velocity v naught. That implies j should be equal to m into v naught. Done. And the next equation is given by the applying the angular momentum impulse momentum theorem on the spherical shell itself. That implies j into h should be equal to 2 by 3 mr square into omega. Okay. So now what we can write is uh, from this to this, we can conserve angular momentum because the only force experienced on the particle is the frictional force, and that torque is zero if we take access on that point lying on the ground itself. So what we can do is from this step to this step, मतलब जो ये पॉइंट है जहाँ पे इसके पास सेंटर मास वेलोसिटी v नॉट आई है और ओमेगा एंगुलर वेलोसिटी आई है, and from that instant to that instant we can conserve angular momentum as well, because the torque of the friction force is passing from the ground itself. Okay, so now writing the equations, what we can write is m v naught into r plus 2 by 3, let call it omega naught, sorry, let call it omega, and let call this one is omega naught, and because this omega naught we know that is omega naught equal to vcm by r because of pure rolling. It is mentioned in the question itself. Okay, so m v naught into r plus 2 by 3 into mr square into omega is equal to m vcm into r plus icm into omega 2 by 3 into mr square into omega. So this value should be equal to this value because of angular momentum conservation, right? So vcm is clearly r into omega. That implies r into omega is vcm. That implies this value is 5 by 3 into m vcm into r, and this value m v naught into r plus clearly j into h is equals to 2 by 3 into m square omega. Okay, leave this one, and it is given the center of mass as the velocity of 4 v naught by 5. It is given as well 4 v naught by 5. Sorry for the inconvenience, but it is given. So it is given 2 by 3 into mr square into omega should be equal to this value, and it is 5 by 3 into m into r into 4 v naught by 5. But I guess this way is already better because we are needed some expression and just given the question itself. That is a good way. When you have shorted something, you get to know that it is given in the question. Fine. I know I am just saying random things, but take 4 mv naught r by 3 minus mv naught r. That is mv naught r by 3. 2 by 3 into mr square into omega should be equal to mv naught into r by 3. That implies m से m cancel. Omega is equal to v naught upon 2r. Fine. Omega is v naught by 2r. Okay, so let's put this value. It is j into h. So m v naught into h should be equal to 2 by 3 into mr square into omega. That is uh, v naught by 2r. So h is clearly r by 3. So for calculation of the energy lost because of friction is what we can do is we can just subtract the initial and kinetic energy. Initial kinetic energy, final kinetic energy. So the initial kinetic energy of the particle is of the basically spherical shell is 1 by 2 into mv naught square plus half ICM into omega square. So it is the initial energy and the final energy is 1 by 2 into mvcm square plus half ICM omega squared, of course. In this case, omega is vcm square by r square. Done? And ICM is 2 by 3 mr square. So 1 by 2 mvcm square plus 1 by 2 into 2 by 3 mr square into vcm square by r square. So this value is 1 by 2 plus 1 by 3, that is 5 by 6 mvcm square. And this value is 1 by 2 into mv naught square plus 1 upon 2 into ICM. ICM is clearly 2 by 3 into mr square multiplied by omega square is value clearly 1 second. V naught square by 4r square. That is V naught square by 4r square. So uh, this value is mv naught square by 2 plus mv naught square by 12. That is 6 upon 6. That is 7 by 12. 7 by 12 mv naught square. Fine. And this value is 5 by 6 mvcm squared. Implies 5 by 6 into m. And vcm is 4 naught by 5. That is given in the question itself. Squared. So just subtract these values. What we got is mv naught square into 5 by 6 into 16 by 25 minus 7 by 12. So this value is 3, this value is 8, this value is 5. So 8 by 25, 8 by 15, sorry. So 1 by 3 into 8 by 5 minus 7 upon 4. That implies 32 minus 35. That is minus 3 upon 20 into 3 into mv naught square. So it is clearly minus mv naught square by 20. That's the answer to this problem. Thank you. I hope you enjoyed the sessions. Please like, share, subscribe it because it's the only motivation to upload such videos. And you know the dedication which I'm providing is something exceptional. Okay, thank you.